In this video, I will go over the homework that follows the lecture 7.0 called The Review of Inverse Functions. And as always, I hope you watch the lecture, as I will be referring to um, the material presented in that lecture as if assuming that you have watched it. So let's go ahead and jump right into the homework. And again, the goal, the main focus is to brush up on the basic skills related to inverse functions. And one of them is we have to be able to find the inverse function when it exists, and when a function is given to you by an equation, the procedure is as follows. We swap x and y, and then we isolate the y variable. So here I'm going to add 9y to both sides and subtract x from both sides, and then I'm going to isolate y by dividing everything by 9 and simplifying, and this is what we call the inverse function of the original function. So let's enter the answer. All right, problem number 2. We have a interesting. So we have drag the two black movable dots initially placed on the upper left corner on the graph window to the point that corresponds to f inverse of 1. So the idea is that when the function is given to you by a graph, to find the its inverse means to reflect the graph of a function over the line y equals x, and that will be the equivalent of swapping x and y. So your x becomes y and your y becomes x. So now the result serves as the inverse function. So here, what I did, I just simply reflected the points through this line. So it's like a mirror reflection. So if you tilt your head 45 degrees to the right, you'll be able to see the symmetry and how this point became this, and this point became this point. Again, reflection is the act of swapping x and y. So 0, 5 becomes 5, 0, and negative 1, 1 becomes 1, comma, negative 1. Now, another basic skill is to be able to identify whether your function is one-to-one. And to be one-to-one means the graph passes the horizontal line test. And if it's a function, it has to pass also the vertical line test to become a function. So one-to-one functions pass both the vertical and horizontal line test. Now, to pass the horizontal line test means you don't have same outputs for different inputs. So this example is not one-to-one function because we have the same output for two different inputs. So when we're verifying a function given to us as a table, whether it's one-to-one, we're basically looking at the y outputs and make sure they're all unique. If they're not unique, then it's not one-to-one. So here I'm inspecting the y outputs, 8, negative 20, 10, 11, negative 3, 18, 9. So it looks like they're all unique, so the function is one-to-one. As I described earlier, so I feel like this actually can belong over here now as the solution to number 4. So if the function is given by a graph, it has to pass the horizontal line test, and this function does not pass it, so it is not one-to-one. So here, to determine if the relation is an inverse of another one, we just have to check for the symmetry over the y equals x line. And again, we do that by tilting our head sideways and inspecting this graph for symmetry, and it does look symmetric to me. So we can pick, let's say, this point. It's roughly 2 1/4 and -5, and that means at -5 the function will be 2 1/4. So it does look symmetric, and therefore those two relations are functions. Sorry, not functions, but inverses of one another. Clearly, the red one is not a function. It doesn't pass the vertical line test. Another one where we have to simply take the points and reflect them manually. So 6, 2 will become 2, 6, and 1, -1 will become -1, 1. So that's the easiest way to actually do the reflection by hand. So at 2 it's going to be 6, and at -1 it's going to be 1. Same thing, right? So we have a one-to-one function, but the table is now arranged vertically. But the condition for a function to be one-to-one, as all of this have to be unique, right? So the outputs have to be unique. So all I have to do is just browse through all the outputs and make sure they don't repeat. And here I see that they do repeat. So at -13 and -5, we have the same output. That means this function is not one-to-one. Here we have same, but it's just arranged as ordered pair. So when you're given a relation as a collection of ordered pairs, we just have to, I'm not going to list all of them here, I'll just describe what we do, what we're going to do. We're going to look at all these y outputs to make sure that they are unique. And we have 0, -7, 0, and I don't even need to know what's here on the right side. We'll already know that it's not one-to-one function because it has same output for two different inputs, so it's not one-to-one. And we finished the homework. If you have any questions about the basics of inverse functions, please let me know.